Welcome to the Explainer. Have you ever just looked down at your phone, tapped a screen, and kind of marveled at how instantly you're connected to the rest of the globe? I mean, we use these devices literally all day, every day. But the infrastructure making it all happen, it's completely invisible to us. So today, we're going to demystify that invisible network. We're breaking down the foundational hardware, the routers, the switches, and the access points that literally brings the internet out of the walls and right into the palms of our hands.
Think about this for a second. How does a YouTube video actually reach your phone? Seriously, when you tap a thumbnail, what exactly is happening behind the scenes? Well, by the end of this explainer, we're going to completely reverse engineer your connection. We'll reveal the concrete physical system operating just behind your screen, turning what feels like literal magic into structured, understandable science.
Okay, let's dive into this. Here's our literal map for the invisible city we're exploring today. We'll start with the network city analogy, move on to routers, switches, and access points, track the journey to YouTube, and finally wrap things up with some troubleshooting. All right, section 1, the network city analogy. Before we get bogged down in heavy technical jargon, we really need to anchor these concepts into the physical world. A computer network works exactly like a city's transportation infrastructure. It's actually a brilliant way to look at it. The router acts like your highway system, right? Moving high-speed traffic in and out of the city limits. The switch operates like your local neighborhood roads, connecting the houses or, devices right next to each other. And finally, the access point is kind of like a wireless air bridge, letting devices that aren't physically bolted down fly over the traffic and still connect to the grid. Together, the whole shebang ensures data can travel absolutely anywhere. Moving on to section 2. Routers, the traffic cops. Let's zoom in on the first major piece of hardware in our digital city. So, by definition, a router connects your home or business network directly to the broader internet. It sits right there between your personal devices and the outside world. It's the ultimate gatekeeper. And let's be super clear about what that actually means. Without this specific device doing its job, your gadgets have zero outside access. I mean, no Netflix, no Google, and absolutely no YouTube. Now, what's really interesting here is looking at the router as a traffic police officer. It's definitely not just a dumb pipe. It actively tells all that incoming and outgoing internet traffic exactly where to go and which direction to take. It manages the flow so data packets don't just crash into one another. Actually, on top of that, the router protects the network with basic security. Think of it standing at the border, checking the traffic, and making sure only the data you specifically requested is allowed back inside. Which brings us to section 3, switches, smart power strips. So we're shifting our focus away from the global internet, hopping off the highway, and cruising down to the local neighborhood level. A switch connects wired devices together locally. Think about a typical office or a crazy gaming setup. You've got desktop computers, printers, gaming consoles, servers. They all need to talk to each other. But your router, it usually only comes with a handful of ports on the back, maybe 4 if you're lucky. So if you need more physical wired connections, you add a switch to literally link all these local devices together. The absolute crucial point to remember is this. A switch is essentially a power strip for networking. Think about it. If you run out of wall outlets for your electronics, what do? You buy a power strip to expand your capacity, right? A switch does the exact same thing, but instead of electricity, it's connecting and managing network traffic. But wait, it's much smarter than a dumb power strip. It actually knows which specific device is plugged into which port. So if your computer sends a document to the printer, the switch routes that data straight to the printer instead of just blasting it uselessly to your gaming console. All right, section 4, access points, radio towers. We've covered the highway, we've covered the local roads. Now we introduce the final foundational puzzle piece that finally frees us from the cables and brings the network directly to our mobile devices. An access point, or AP for short, provides Wi-Fi. It's what allows your phones, your tablets, your laptops to connect completely wirelessly. It is the crucial link that lets your phone pull up a list of available Wi-Fi names, lock onto one, and then get internet access routed all the way back through the rest of the network. Think of the access point as a literal wireless radio tower. It takes the wired internet connection it receives from the switch, translates it, and just broadcasts it as invisible Wi-Fi signals through the air to nearby devices. It's just like how a radio in your car picks up a station when you drive close enough to a local transmission tower. Your phone just picks up your Wi-Fi when you get close enough to the access point. Now at this point, you're probably thinking, wait a second, I only have one blinking box sitting in my living room, not 3. And hey, that is completely normal. Most home networks use an all-in-one box provided by an ISP, like Xfinity, AT&T, Verizon.
That single piece of plastic actually contains a router, a small switch, and a Wi-Fi access point, all completely baked into one unit. But business networks, they take a totally different approach because they need way better performance, massive Wi-Fi coverage across giant buildings, and the capacity to handle hundreds of users. They separate these roles. They'll buy a dedicated firewall router, massive standalone switches with dozens of ports, and mount multiple access points to the ceilings all over the building.
Next up, Section 5, the journey to YouTube.
Okay, let's move to this and see how it all builds together, because this is kind of the climax of our explainer. We've got all three pieces of hardware on the board, so let's finally answer our initial question. Imagine you're holding your phone right now, and you click on a YouTube video. Bam! Step 1, your phone sends an invisible data request through the air straight to the access point. Step 2, the access point catches that wireless signal, translates it into a wired signal, and shoots it down a cable to the switch. Step 3, the switch looks at the data, realizes, oh, this is meant for the outside world, and passes it along the wires to the router. And Step 4, the router acts as the traffic cop, safely directing your request out of your building, onto the internet highway, all the way to YouTube servers. And then, YouTube sends the video data back following the exact same path in reverse, down from the internet, to the router, over to the switch, up to the access point, and finally through the air right to your screen. It feels like magic, right? Except, actually, scratch that, it's just brilliant infrastructure. Just to totally lock in exactly what we've learned, here's a super easy way to remember the core functions. The router connects you to the internet. The switch connects your wired devices together. And the access point connects your wireless devices. It really is that wonderfully simple at its core. Finally, Section 6, troubleshooting your network. Now, this knowledge isn't just theoretical. Understanding this data path is actually an incredible practical superpower. Whenever something breaks on a network, beginners usually panic. But you don't have to anymore. Just think about the path. If one part fails, the connection breaks. For example, if nothing in your house can reach the internet at all, well, the gateway is down. Check your router's power or call your ISP for an outage. If your desktop PC isn't connecting but your phone's Wi-Fi is fine, the problem is local. Check the switch power, the Ethernet cables, or those little blinking port lights. And if only the Wi-Fi is down, but your wired desktop is working perfectly, the air bridge is broken. Check the access point's power and signal. By isolating the hardware based on its specific job, network troubleshooting becomes totally logical, instead of just wildly frustrating. So you now know exactly how devices connect, communicate, and reach out to the wider web. You literally know the physical path the data takes. But I want to leave you with a bit of a provocative question to chew on. You know the path, but with all that traffic constantly flowing in and out of your personal digital city, how do we keep it secure? How do we stop the bad traffic from just taking that exact same highway right on in? That opens the door to some incredibly fascinating concepts like IP addresses, DNS, and of course, firewalls. But we're going to have to save that for another time. Thank you so much for learning with me today, and I really hope you never look at a YouTube video the exact same way again.